Okay, I'll try not to yell at it. If I do, somebody just tell me to lower it down a little bit. I'm used to conference speaking in much larger rooms, so I tend to project. So first off, thanks everybody for actually coming out. And anybody who actually works on the project or in the community, thank you for your work. I've been doing this for some time now, and without some of that, I wouldn't be able to do what I do. So I both get to keep and lose my sanity because of all you. So I want to say thank you to some of the people that are actually crazy enough to be here and prepare yourselves for what I would refer to as some Pastafarian nightmare spaghetti monster of what I do. Now, this is all made possible thanks to the Helm project and several of the partners that we have throughout the project and community. So let me just go ahead and get started. Let's set some of the groundwork here. I need to understand the scale that we're working with, all right? The size and complexity of the application that I'm trying to deploy might look like I'm lying to you at first. Until you actually dig in a little bit and see what I'm actually talking about, you don't understand the suite and you don't understand the challenge that we're actually trying to address. So let's look at scale. Now, we have 5 external dependencies. That's it, right? Well, there's some of them that are actually forked because we need to make changes that weren't ready for being upstreamed, or we knew that upstream wouldn't necessarily accept, or we just had to integrate so tightly with it that we didn't have a choice. So we have a few of them that are actually forked from upstream, and we have a few of them that are developed completely in parallel because the upstreams didn't exist when we started, and we didn't think ours was quality enough at the time. But then we also have 10 and counting internal charts that we have to keep in line, orchestrated, and interwoven. Fully enabled right now, excluding our operator, that's approximately 6,000 lines and counting of output. Now, who wants to tell me the largest chart that they know of on the public repositories? Pick a number. Any number. You can be wrong. I expect you to be. It's cool. Pick a number. What's the most output of a public chart at this time by line count? There are a lot of charts that actually do spit out several hundred lines. Somewhere between the range of 300 and 600 is the average chart. So to give you the visibility and scale, that's relatively 1/10 our size. Now, to be fair, that's also because we're basically spitting out 19 charts in one. So understand that goes to show the level of complexity that we have to deal with. So when I tell you that we have to deal with an entire application suite, I am not joking. This is the public architecture documentation that we have that actually outlines all the components and ways that things interact. Our chart isn't even all of this yet, okay? When people think of GitLab, they think it's an application, it's what they interface with. In reality, it's an entire suite of applications behind it that we have to keep very tightly integrated, interwoven, and orchestrated no matter what platform that is. Now, our chart can't actually be as simple. If our edict is to be self-contained and manageable and scalable, we have to actually do some complex things in the background. We can't make a great new deployment method and then immediately tell our customers, hey, here's our awesome new way to do things. By the way, it's harder. Which, if you're coming from the omnibus GitLab land, so operating in standard VM deployments, it really is as simple as apt-get install GitLab. So I have to make the Helm charts and the use of Kubernetes as easy as Helm install GitLab, or at least try really hard to do that. And I need you to remember, though, not everybody understands what we're doing, okay? They have to be very, very simple to use while being extremely complex in the background. But at the same time, development perspective, those of us working on complex charts of any kind, we're working with suites of charts put together, orchestrating all of that gets hard, especially when you have competing styles or maintainability issues and kind of keeping all those things straight. And then we have to remember that our target consumer may not understand the depth of Helm, so they may not be able to make small modifications to make it work. And it's possible they don't really understand Kubernetes at all when you stop and think about it. They could be just an application developer that needs to install a tool that they can use, or they could be just a Kubernetes administrator who's never seen an application this complex before. This is not a knock to anybody who might want to use the chart. We're talking about new technologies. Kubernetes itself as a project is barely 5 years old. Helm as a project is not even half that. We're doing things with technology that were not imagined 15 years ago when the cloud got big and people started understanding virtual machines and how to work with them. We are changing the way people think about application deployment. So you need to understand not everybody has caught up yet. And thus, I need to do things in a couple of interesting ways. So what's my actual challenge with these charts? It's pretty simple. I've got to be able to install the charts on any cloud with as few commands as possible. Any cloud, one command is the challenge itself. We do our darndest, to say the least, but not everything is completely perfect. The idea being that you can simply add the repo, pull your updates, and actually run the install command with as little configuration as possible. Now, that one in particular says timeout of 600. If you're deploying everything and your cluster is not sized correctly, that might take longer, just due to pressures. But ideally, if it takes you 10 minutes to deploy, maybe you need to figure out what's going on with your administrator to make sure that everything's keeping up. So let me explain why we need to make the move to cloud native. We've been developing the Omnibus GitLab for years. It's great. No, really, it is actually awesome to use. It's also inspiringly large, complex, and heavy. That thing is now over 1.5 gigs, okay, compressed. But, needless to say, it's a monolith. Monoliths only get you so far. At KubeCon in Seattle, I gave a presentation outlining our work and progress at the time, but I'm just going to summarize that here. The Omnibus is massive. When you multiply that size and complexity with the size and complexity of deploying a multi-million user SaaS, you learn the meaning of growing pains empirically. We got to the point where we were on our nth iteration on the in-house development and deployment tools, and we realized we really need to make progress on this, on something that's more maintainable for the future and designed for the future. So let's set some grounding here, right? This particular meme came up just the other day, and it was so timely I had to put it in. Why is this thing so massive? Our goal is to actually encompass the entire development lifecycle as a tool while dogfooding it all while we prove it. As a result, that means that we're incorporating all the tools that we use, if not making new ones to fill in those gaps. And I know there's some people who are going to be, why not do this piece by piece? Why not chart by chart, Unix style, one thing does one thing well? Okay, cool. If I told you to deploy that, right, would you think, hey, this is easy? Really? Which one of us is lying to ourselves? Because I just showed you that architecture graph. If you had to deploy every single component and keep track of all the interconnections, the secrets, the TLS for every single component, how long would that take you to do manually? That's the level of complexity that I face so that you don't have to. Then we have to worry about the basic things. What are our targets in the project, right? It's got to be maintainable. Number one, absolute, with something this large, you've got to be able to maintain it as it grows, even if it mutates. If you lose this fight, the game is over, because you won't be able to manage it, which means you can't use it, which means your consumers can't use it. Whether that's in-house or out-of-house, doesn't matter. It's got to be flexible, and I mean really flexible. This is the close second. It was really hard for me to separate it between maintainability, but if I can't use it, it doesn't matter, right? The chart will be deployed either as a sum whole, and with very little modification for most people. But for others, say customers running several thousand users or tens of thousands of users or hundreds of thousands of users, it's got to be able to be swapped component by component with the existing patterns. And I have to be able to roll from an architecture that's been in deployment for 5 to 10 years and then slowly migrate all components over. Because if you have a global customer that's in every single region, he can't have the downtime, because if he does it while the Americans are asleep, well, that's going to mess with everybody in APAC and probably make for a bad morning over here in EMEA, right? So I have to be able to install all or part or just the minimum requirements. For us, downtime is insanely costly. I can't make that mistake to where I break things and force you to do pump and dump, right? Back it up, drop it, throw it into production again. Can't do that, right? It's a bad thing for us, it's a bad PR, and it's really bad for any of our customers, and we have a lot. The last thing in this project is it has to be industry accepted. This new method has to be able to make use of industry recognized tools with a level of maturity that's sufficient to know that we're not going to be facing large sweeping changes in the future, that we're not going to get broken things in between major releases, or I should say minor releases. Major releases, hey, we all know what's coming, and I look forward to it. But it also has to be adopted broadly enough throughout all my customers that they'll actually make use of the thing I'm doing. We had choices when we started this project, a little over 2 years ago, and Helm was the best choice that was available at the time, and personally, I think that's the best decision we could have made. We definitely think it has the highest traction at this point, and soon, with more flexibility coming, it'll gain even more. So let's get to the gory details, because let's face it, that's why y'all came, right? So we make extremely heavy use of templating, and by extremely, I mean that. That list, the project's open, you guys can see this. This is 40 plus of our templates, plus a couple of the templates that are forked. It's insane the amount of templating we make use of. But we do it for very good, very solid reasons. And sometimes people don't believe why we're doing it the way we do it. Some people don't believe that it's required. And you know what? When you see something this big, it's not. When you see something this big, it gets really hard to not. Now, I wish that we could condense this and maybe even separate out our charts so that we don't have one big monolithic chart. But with as many templates as we have here, if we could do that, we would do that. But remember that library charts aren't here yet. So I have to make do as best I can with the tools that I have. So we have to worry about the values that we're templating, the sections of config maps or repeated chunks of code, right? This is what library charts will eventually do. And we also have to worry about our globals. One of the things we do is, as you saw in the previous slides, I have all of these individual sections of primary helpers. These are actually whole sections of configuration or even individual values or comprised values, so that I actually have a way to say, I don't have to create the URL for the API server 15 times. I can set the template once and then just include the template in line and it'll actually work. This is one such example. What we're doing here is literally just give me the host name for the actual GitLab instance. That'll be reused later as part of the URL. It'll be reused for API endpoint values. It'll be reused for any number of things. But you'll notice we have the internal template for assemble host, which actually pulls together some of the things so that you don't have to set as many values, but also the specific value provided through our global setup. And I'll cover globals in a second. But we have our global host and GitLab. So the actual GitLab API instance, you can specify its name directly outside of our defined patterns if you choose. Otherwise, we'll actually go and assemble that for you. So we actually have chart values plus global values plus assembled value and then the ability to override that if you choose. Yes, that's a stack and stack and stack of things. But remember, Helm 2 only has Go template text with Sprig and a couple of salt functions, right? We don't have Lua. We don't have the ability to programmatically do this. We had to do this by dealing with the output of templates stacked upon each other. And remember that that is always text, right? So you have some limitations in the ecosystem and the tools that we have to work around. So there we go. Let's set a few ground rules on what we're actually doing when it comes to our templates. We have a document out there in our documentation that specifically says architecture decisions. I'm going to cover a few of those and how they specifically relate to the depth and use of our templates. Is because library charts don't exist yet, we have to make sure that the template partials, whenever we use them, are as close to the chart that needs it, but not all the way in the global space. Imagine if I had one templates folder at the head that had all 45 template files in it. Or worse, one template file that was all 45 in one. If you opened a 2,600 line file for a template file, would you like, where the heck did I put stuff in here? Now imagine instead of 2,600 lines, that's closer to 100,000 lines. You don't do that. We have to be able to structure these specifically. Now I've actually kind of dropped a few things in here right out of our documentation, but I want to point out that the reason we're doing it this way is we needed to be able to use dry patterns. You know, we don't keep repeating ourselves all the time. If we can use it once and do it through a template, do it that way. And remember that templates are actually global. So you can stack them and the first one read in through hierarchy is the one that actually wins by that name. It's kind of a dynamic JIT, but not quite. That comes into play in the way we use things. Because, for example, we actually override the PostgreSQL service name so that we can deploy PostgreSQL, but also know exactly what its name's going to be and have that be controlled by our chart instead of the downstream chart. That has actually come into play throughout the entire chart in dealing with some of the forks that we've had to deal with, but it's a particular case that I have to point out. So here's another one. This is one that's unique to us as far as I've found. We actually have a pattern in place that makes use of Helm templates to specifically detect a configuration that was passed that would actually be deprecated in a future release. So if we know that we need to move configuration values, we actually intentionally make use of the fail logic that's available to actually do as close as we can get programmatic checks on the values and tell you, okay, this was moved to a secret, please create that and move that value here. Here's the link to the documentation. Or, hey, we moved this entire configuration for SAML auth from the individual chart up to a global property because we realized that it needed to be set in 6 different charts, not 1. This allows us to actually have rolling changes in minor releases without going, oh, just broke 15 people in production, because that would be bad to say the least. And let's face it, not everybody has a full change management in place. So if we don't try to protect them just a little bit, we'll end up breaking a lot of people in bad ways, and that's a nasty support call for us and not great PR either as a product. Now, we intentionally try to do these both during install and during upgrade. I will point out, though, that when you use our chart, we actually specifically document to never use the reuse values flag. Does anybody here know why reuse value is bad and dangerous? It does not take in new default values. So if you deploy the chart at one revision, and then I go and make a new revision, and I've added, say, a new dependency that requires defaults, and you say, Helm, upgrade, tac, reuse values. There's a whole sections of value defaults that are no longer present. That template will fail and fail horribly and not explain to you why. So we actually ask people to use Helm get values and then pass that in to Helm upgrade. The reason being, Now we don't have to worry about new default values not coming through. They'll get rolled in, and Tiller will actually behave appropriately. This one has bitten us in the community before. Just I had to address it because I have so many dependent trees, and I've had a lot of properties have to move over time. The next thing I have is, based on that same kind of logic, is the ability to actually check for configuration that will be bad. An example, we have both Redis and Redis HA. We have them as separate forks because of another choice that I'll talk about in a minute. But if you tried to deploy Redis and Redis HA, which one am I going to hook the application to? Why am I going to consume both sets of resources? Which one's going to win the service name war? That's like, why would you do that? It's a mistake, but it's a mistake that more than one person has made or could make. So we use the same kind of logic in deprecations, which I can show you at the end if you choose, so that if we detect that you've set two values that are competing, or that you've set a value but not set a dependent value, we will actually stop you from deploying the chart and deploying a known broken state. So when we can find and detect those, we prevent people from doing that. Then we have the very pervasive use of values.global. And when I say pervasive, meaning if you do a Helm install dry run, debug, and look at the output, you will see what you put in, which is anywhere between 1 and 60 values, depending on how tweaky you get with the settings. However, when you go to computed values, you're going to see the same list of global default behaviors a lot. But that's because we don't want to have to configure everything 10 times. We don't want you to have to configure everything 10 times. Say you want to use an existing production grade HA, region resilient Postgres, right? Whether that's using Cloud SQL, whether that's using the updated charts from Bitnami, you need to be able to configure that. Now imagine that I have to tell every single individual component, hey, Postgres is over there. Hey, Postgres is over there. Hey, here's Postgres secret over here. Imagine I had to do that to every component out of the 11 that need that information. Would that drive you insane having to copy and paste the same values into the settings all the time? I mean, cool, you could do it, and with Helm 3 you start to get partials and things like that, and you can kind of use customize, but if you use customize, then it's more Helm template, pass-through customize, pass-through, right? I can do it this way. It's usable, it's manageable. I have a secured template set that I know are going to behave the right way, and I can put them in place. On top of that, I can check one place for a broken configuration. If you tell me that, hey, here's the external, and you didn't bother to tell me whether or not you want SSL, let alone if there's a password on it, I'm probably going to tell you, you're using external Postgres, why are you not using a password, right? This comes into play specifically when it comes to Redis and Postgres. I have approached Bitnami at KubeCon in Seattle, and then I met with them again in Barcelona and said, look, it's nice that I can configure it this way, but there's a lot of fight I have to deal with. Because if I need to set PostgreSQL, I have to override this and I have to override this, but I don't want to keep maintaining my own fork. First off, I have an old fork. Second off, I'd rather make use of the community resources if at all possible. So I've worked with them, and you'll actually see certain things in the global patterns begin to come up in the charts that they're coming into play because they've recognized some of these patterns are useful. So hopefully you guys will see that as well. I'm not saying everything should be global. I am saying if I can configure one set of values once and we can all abide by them, it will save everybody a lot of maintenance time. Second, this is different. We do not put secrets in environment ever. I don't care if it's an end from secret key. I don't do it. I don't do it. I don't do it. Now, this stems from the 12-factor app. Everybody familiar with containerization, 12-factor app, and all this stuff? Right? I'm getting a bunch of nods, a couple of head tilts. Okay. We actually make use of an init container that populates all secret content. Yes, this does mean when the secrets change, some of our pods have to be fully restarted. instead of allowing it to just be hupped and pick up the new values, right? Now, the reason is, one of the things that our customers do often is make use of GitLab Runner. GitLab Runner, if they're going to use some of their existing workflows, includes the use of Docker and Docker. Docker and Docker entails the access of what flag in Kubernetes? Privileged. What does privilege do? It gives you the ability to actually query the underlying runtime. This is a problem. Why? Because Docker info is something that'll get run, and you'll see it run in the APL logs all the time. But that then contains a huge amount of actual secret data if you put it in the environment. So in order to protect our users and prevent bad habits, we don't allow environment in secrets ever. We instead put a container in place that actually populates those values and then passes them through ephemeral tempfs over to the running container. That allows us to be a little agnostic about where that content comes from, so we can use KMS, we can use Vault, we can use AWS. It doesn't really matter. But our application then also doesn't have to change or be knowledgeable of those secrets. We can just, bam, it works. So I'm almost done. And I'll let people ask me all kinds of questions for the rest of the day. But I want to say thank you to the maintainers of the other projects that we make heavy use of, being Nginx, and specifically their reluctant support of TCP connections. We really appreciate that you listened to us when we said we really would like to not break all of our users that are using SSH. Please. I will actually be putting forward a patch to make it not reset all TCP balancing when you need to make a change to the ports. I want to thank Bitnami for the work that they've done in the major changes to PostgreSQL, Redis, and upcoming MinIO. That's going to help me significantly because I can please stop forking these things, because I'd rather stay closer to mainstream than anything else. And especially to JetStack. If you guys aren't familiar with JetStack and the things that they do within the community, both Kubernetes and Helm, specifically with their work with Cert Manager, I really appreciate the work that they have done, the education that they're doing to the users and contributors. It's great stuff. So with the 1 minute that I have, anybody want to get a question on record? If not on record, you can see me in 3 minutes. It'll be cool.
Ever since you launched the Helm charts as publicly available, how has adoption been by the GitLab users?
The question was, ever since our public GA, how has the adoption been by our GitLab users of the Helm charts? The adoption is definitely slow, but it's not due to the fact that the Helm charts are new per se. Obviously we have things that we need to add to it. We need to be better at a certain number of things, and we have an open tracker. But we have large customers, anywhere between 1,000 and 50,000, that are actually making use of the charts. I will not tell you that the mainstay of our users are going to be moving to Kubernetes anytime soon. Mostly it's customers that already have Kubernetes or have a roadmap that includes it, and then realize that we have this as an option. Mm-hmm. Anybody else quickly? The question is, with all of those charts, how painful is it to go through all that YAML? As a developer, I'm quite familiar with it. The easiest way is honestly to run Helm templates on the output and then search for the known path of where the thing's coming from. But if you output the whole thing and actually try to manually read 6,000 plus lines of YAML, yeah, your eyes are going to hurt after a little bit. You need to know which section you're looking for, 100%.
So if I have all the infrastructure already in place, Cert Manager, Ingress, what would you recommend me to do? Because when I try to do all these things for me.
So the question was, if I already have existing infrastructure, example, Cert Manager, Nginx, and a Postgres, for example, what should they make use of? The chart is designed componentized. It's designed to be deployed as a whole, but again, because we have to roll over, every single component is interchangeable. We actually have documentation in place to use an external Cert Manager, an external Nginx or Trafic, as well as external Postgres, object storage, Redis, even to outmode any particular state data, because Postgres was not stateful ready when we started this work. And our Gitly service, which is an RPC network service for Git, this is something that often people actually run outside so they can make safe use of NFS to do replication. So
Basically flags I can.
it's literally flags and a couple of values, yeah. Okay. I believe I am stuck to time, so thank you everybody for coming out.